Okay, I'm going to show a couple problems on how to solve a quadratic equation by completing the square. So, solve by completing the square. The problem is x squared minus 10x plus 27 equals 0. So it's a quadratic equation because it's a degree 2. Lead coefficient needs to be a 1. Lead coefficient is the number in front of the highest exponent term. It is a 1. We're good to go. So next step is the constant has to be isolated by itself. So we're going to move the constant over to the right hand side, get it isolated, change sides, change signs, and then they call it completing the square, so I always have students draw squares. We're going to change the looks of this equation, but we cannot change the value of it. To get the number that goes in the box, you grab the middle term, not the sign, not the variable, just the number. It's a 10. You cut that number in half, and then you square it. So 10 cut in half is 5, and then 5 squared is 25. 25 will be the magic number that goes in the boxes. Whatever you add to the left side of the equation, you have to add that same number to the right side of the equation. So you have just created a trinomial over here on the left-hand side that will factor to be some quantity times itself. It will be a square. So you factor that left-hand side, x, constant is positive, so you look to the middle, get your signs. My signs will be minus, minus, and then numbers that multiply to 25 that add up to 10 would be 5 and 5. So that's how that trinomial factors, which we're going to write as x minus 5 quantity squared. Over here on the right hand side, negative 27 plus 25 is a negative 2. So now we have x minus 5 quantity squared equals negative 2. We need to finish solving for the variable x. I need to get rid of the exponent of a 2, hit both sides with a square root, hit the number side with a positive and a negative. When you hit something squared with a square root, it always gives you what's underneath by itself. And then we have x minus 5 equals plus or minus the square root of negative 2. We're going to finish the problem off by moving the minus 5 over. Change sides, change signs. So it's going to be 5 plus or minus, and then square roots of negative numbers are imaginary numbers. So anytime you come across the square root of a negative number, you're going to write the square root of the number times I because it's an imaginary number. So you're going to write the square root of 2 times I, and those are the two answers to this quadratic equation. They are not real solutions, they are two complex answers. 5 plus the square root of 2i and 5 minus the square root of 2i. So that's that problem. One more problem I'm going to do on completing a square. You'll see why I'm doing this one. This one's just a little harder. So, solve by completing the square again. One more time using this method. Lead coefficient is a 1, great. Move the constant over, get it isolated by itself. So we have x squared plus 5x, change sides, change signs. A plus 24 on the left is going to be a negative 24 on the right. They call it completing a square. So we put squares on both sides to get that magic number that goes in the box. You're going to grab the middle term, not the sign, not the variable, just the number. It's a 5. You're going to cut it in half. 5 cut in half is 5 halves. I know it's also 2.5, but stay fractions. Don't go decimal, on me. 5 halves squared is 5 halves times 5 halves. That is 25 over 4. 25 over 4 is what we need to add to both sides of the equation. So I add 25 fourths to both sides of the equation. Right here, we got to factor this trinomial. It will always factor to be some quantity times itself. x, x, constant's positive, so you look to the middle to get your signs. It's going to be plus, plus, and then these numbers here will always be your middle term cut in half. 5 cut in half is 5 halves, so 5 halves and 5 halves. 5 halves times 5 halves gives us our 25 over 4, and 2.5x, 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 our nose and smiley face, 2.5x plus 2.5x adds up to our middle term 5x. So that's the way she factors. Over here, we have to add or subtract fractions. Well, anytime you add or subtract fractions, you have to have a common denominator. So I put this over 1. Common denominator will be 4. So negative 24 over 1 plus 25 over 4. Common denominator is 4. So this needs to get multiplied by a 4. Negative 24 times 4 is a negative 96 plus 25 over 4. And negative 96 plus 25, we have a common denominator now. The difference there is what? 71. So we get equals negative 71 over 4 is what we have on the right hand side of the equation. So we have x plus 5 halves quantity squared, which, as I said, this number right here will always be the middle term cut in half, always and forever, equals negative 71 over 4. And then I need to get rid of the exponent of a 2, hit both sides with a square root, hit the number side with a positive and a negative. So this gives me x plus 5 halves equals plus or minus. Anytime you have the square root of a fraction, numerator and denominator, top and bottom, gets its own square root. So I'm going to write the negative square root of 71 over the square root of 4. Move the 5 halves over to finish it off. Change sides, change signs. So we have negative 5 halves plus or minus. The square root of negative 71 is going to be written as the square root of 71 times I, because it's an imaginary number. And the square root of 4 is 2. So my two answers to this problem are negative 5 halves plus square root of 71 I over 2, and negative 5 halves minus square root of 71 over 2 I.